Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. If this is the first time you come across my channel, welcome, and I am super excited to have you join in on today's video tutorial and hopefully all the tutorials that I'll be uploading. And if you are a learner that regularly watches my video tutorials, thank you so much for watching the videos. Please make sure that you drop me a comment and tell me how you found the video tutorials. Also, please make sure you give this video a huge thumbs up. It will really help the channel reach more learners that struggle with mathematics. So enough with all the chit chat. Let's get started with what you came here for, and that's today's easy to follow mathematics tutorial. Alright, so without any further ado, let's get started. So on today's video tutorial, we are going to be going through question 3 of the November 2020 Paper 2 Grade 12 exam to help grade 12s as well as grade 11s prepare for their final exams, right? So this question basically covers a topic on analytical geometry, right? And I basically covered this section on my channel. I'm going to make sure that I hook you guys up with the link to the video on the description box. So if you're wondering what I'm talking about, what summary is she talking about, just check out my description box. I made a very cool summary on all that you need to know on analytical geometry to properly prepare you for your section on analytical geometry in your tests and in your exams. So before we get started, just quickly pause the video at this point and just quickly write down all the questions, draw the diagram, get your highlighters, get your pencils and your pen and your ruler as well as your calculator. And after that, just attempt the question on your own. So if you've already done analytical geometry and you've went through the section and you've done your summary and you understand it, then just copy this question down, all right, attempt it on your own first and then play the video to see if you really understood the important concepts, because that is the most effective way that you are going to learn, if you try it on your own first and then you watch the video to see if you are following. All right, so let's just read question 3, right? It says that we've got triangle TSK is drawn. The equation of ST is y is equal to a half x plus 6, and ST cuts the x-axis at M, right? We are given the coordinates of W, which are -4 and 4, and we are told that W lies on ST and R lies on SK, such that WR is parallel to the y-axis. WK cuts the x-axis at V and the y-axis at the point P, which has the coordinates 0 and -4. And then we are also told that KS produced cuts the x-axis at N. And then on our triangle TSK, so our triangle TSK, we know that we've got S is equal to our angle theta. Alright, so question 3.1 says that we need to calculate the gradient of WP. Alright, so which line is our line WP? So basically what you're supposed to do is highlight that line so that you see what you're working with. Right? So that is our line WP there, right? And we need to basically calculate the gradient of WP. What do we see? We see that we are given the coordinates of W, and we also see that we are given the coordinates of P, right? So that just makes it super easy to calculate the gradient of WP, right? Because we've got 2 points and we know the formula for calculating the gradient to being the gradient of WP is equal to, so the gradient of WP is equal to, the formula is y2 minus y1 all over x2 minus x1, right? So what I do is I always label my points. So I'm going to probably call this my point 1, the W is point 1, and the P is my point 2. So we just simply substitute. So our y2 will be the 4 minus the y1. So our y2 is going to be equal to our negative 4. And our y1 is going to be our 4 all over our x2 is the 0 minus our x1, which is our negative 4. Okay, so you simply just put that into your calculator. So it's negative 4 all over 0 minus 4. And we find that our gradient for our line WP is equal to negative 2. Alright, this is our 3.1. We are done. Next question. Show that WP is perpendicular to ST. Alright, so we've already highlighted our WP and we need to show that it is perpendicular to our ST. So I just need to highlight my ST so that we see which line we are working with. Right, so this is our ST and we have to prove that these two lines are perpendicular to each other. How do we prove that lines are perpendicular to each other? Do you guys still remember how we prove whether two lines are perpendicular to each other? Alright, if you don't remember, you need to go watch that summary video that I've created for you guys, but I'm still going to explain. Right, we can prove that two lines are perpendicular to each other if you can prove that the product of the gradients are equal to negative 1. Right, so we need to prove that, we need to show actually that the gradient of WP multiplied by the gradient of ST is equal to negative 1. And if we can show this, then we have proven that these two lines are perpendicular to each other. Right, so we've already got the gradient of WP, which is negative 2. And guys, do you still remember we are given the equation of the line ST? Right, so I'm just going to move our page down so that you can see. Right, we're given the equation of our line ST, and our line ST is equal to y is equal to a half x plus 6. Right, so this is our equation of our line ST. So what we're going to do is we're going to just take the gradient of our WP, which is negative 2, and then multiplied by your gradient of our ST. And what is our gradient of our ST? It's the the 1 over 2, right? So the gradient of ST is 1 over 2. And let's check if the product of these two numbers gives us negative 1, right? And it does in fact give us negative 1. Therefore, we can confirm that, right? We can confirm that our WP is in fact perpendicular to ST. Question 3.3. If the equation of SK is given as 5y plus 2x plus 60, which is equal to 0, calculate the coordinates of S. So the first thing that I always do is just highlight the line that we're working with. So we know that we are told that the equation of SK is equal to 5y plus 2x plus 60, which is equal to 0. So that is our line SK. So our line SK is that line there. Alright? Okay. So we need to calculate the coordinates of our point S. Alright. So how do we calculate the coordinates of S? What's the most important thing that's happening at our point S? So let's just look at our diagram and just try to figure out if there's something important that is happening at our point S. So the important thing that is happening at our point S is that we've got line SK intersecting with line ST. Right. So at point S, we've got two lines that are intersecting. And what do we know about two lines that are intersecting? We know that we can simply solve the equations of those two lines simultaneously to get the coordinates of point S. Alright, so we basically are going to work with the equation of line SK, and we are going to work with the equation of line SK, and then we're going to also work with the equation of line ST, right, to get the coordinate and solve those equations simultaneously to get the coordinates of S. Okay, so let's do that. All right, so we already given the equation of our line SK, right? So we're just going to quickly write that down. Okay, and our line SK is given as, right? It is given as 5y plus 2x plus 60, which is equal to 0. But we need to get this equation of the line SK in the form of y, which is equal to mx plus c, right? By getting it in that form, you will see that this is actually an equation of a line, of a straight line, right? Because when it's in this form, it can be a bit confusing because you don't really see what's happening, right? You don't really see that this is actually an equation of a straight line, right? So we're just going to get it into the form of y, which is equal to mx plus c, right? By making your y the subject of the formula, right? So you're going to have 5y, which is equal to, you're going to move your 2x to the right hand side, and you're also going to move your 60 to the right hand side. And you are going to have negative 2x minus 60, right? And you're going to simply solve for y. Okay, divide by 5. And you're going to have your y is equal to negative 2x all over 5 minus 60 divided by 5. Negative 60 divided by 5 is negative 12, right? So this is our equation of our line SK. So I also mentioned that we already have the equation of our line SK, and we basically also need the equation of our line ST, and we basically have to solve these two equations simultaneously to get our coordinates of our point S, right? We're already given the equation of our line ST, and that is y is equal to half x plus 6. So we are just going to put that in. So our line ST is equal to y is equal to a half x plus 6. And we know that now your line SK is equal to y, which is equal to negative 2 over 5x minus 12, right? So we know when you're solving equations simultaneously, obviously you have an equation 1 and we also have an equation 2. And what we are going to do is we are going to substitute equation 1 into our equation 2 and see what we get. So that's basically what I'm doing now. I'm substituting my equation 1 into my equation 2. And like you remember, so let's just move back. So that was my equation 1 and this one is my equation 2. And I'm going to basically substitute these two equations into one another. Alright. So I'm going to have 1 over 2x plus 6 is equal to negative 2 over 5 x minus 12, right? You're going to move the x values to one side. So it's 1 over 2x plus 2 over 5x is equal to the negative 12 minus 6. So 1 over 2 plus 2 over 5 is going to give you 9 over 10x. And that is equal to negative 12, negative 6 is going to be equal to negative 18, right? And we're just going to solve for our x. And to solve for our x, basically need to multiply by 10 over 9 on the left hand side, and you multiply by 10 over 9 on your right hand side, right? And then you're going to have x is equal to negative 18 multiplied by 10 over 9. And you're going to have your x to be equal to 20, right? So now we've already found the x coordinates of our point S, right? So what's missing, right? We need to basically find the y coordinates of our point S. And how do you find the y coordinates? You can basically substitute this x value that we have obtained in either equation 1 or our equation 2, right? So we're going to substitute the x value that we've obtained of x is equal to negative 20. You can either substitute it into our equation 1 or you can either substitute it into our equation 2. It's going to give you the same value. All right, so I'm just going to substitute it, my x value into my equation 1, and I'm going to see what value I get. So my equation 1 was y is equal to 1 over 2x plus 60, and then we're going to substitute that x value there. So it's going to be y is equal to a half negative 20. So where you see the x, you're going to put the negative 20 plus 6. And you're going to find that your y value, your y coordinates for our point S is equal to negative 4, right? Therefore, the coordinates of our point S is negative 20 and negative 4. Okay, so we've already calculated the gradient for our WP. We've already shown that WP is perpendicular to ST, and we have calculated the coordinates of our S. Right. So the next question, which is 3.4, wants us to calculate the length of WR. Okay, so what I'm going to do, I'm just going to highlight my WR for you guys. Okay, so this is my WR, and we basically need to calculate the length of this line, right? And then what do we know? How do we calculate the length of a line? We use the distance formula. That's the first thing we know. And the second thing that we also know is that to be able to use the distance formula, we need 2 points, right? So we already have the point for W, but we've got a problem. Right, we've got a problem. We do not have the points for R, right? So we need to get the coordinates of R so that we can basically substitute the coordinates of W and the coordinates of R into our distance formula to calculate the length of WR. So now, how do we calculate the coordinates of R, right? How do we do that? Okay, so we are already given information. Okay, we're given information. And the information tells us that, okay, let's just go that our WR, right, WR is parallel to the y-axis, right? So our line WR is just a straight line. It doesn't really have a gradient, so you don't really have to stress about that, right? So because we know that it's parallel to the y-axis, we know that it's just a straight line, right? And another thing that we can see, because it's a straight line, we have just a straight line. That straight line is called the x is equal to negative 4 line, right? So I'm just going to highlight my WR. So that's the WR here, right? And they told us that it is parallel to the y-axis, meaning that it's just a straight line that goes to the x point, which is x is equal to negative 4, right? And then this line means that the x which is equal to negative 4 is a line that goes all the way to your point R, meaning that the x coordinates of our R is equal to negative 4. Okay, so the x coordinates of your R is negative 4, and we just need to get the y coordinates. And then once we found the y coordinates, we can simply use the distance formula and substitute both these coordinates to get the length of WR. Okay, but now how do we get the y coordinates of our R? Okay, so we already have the equation of our line is K. Remember, guys, we were given the equation of our line SK, and we put it in our standard form of y, which is equal to mx plus c, right? So we already know this equation, right? We already know this equation. So now this question is pretty simple. If we know the equation of SK and we already know the x coordinates of our R, then what we're going to do is we're going to substitute that x coordinates of our R into our equation of our line SK to give us the y coordinates of our R. Okay, I'm going to repeat that, guys, right? So we already know that our x coordinates of our R is equal to negative 4 because we are told that the line WR is parallel to the y-axis, right? So what that tells us is that it's just a straight line that goes all the way from that point W and goes down to your R, right? So the x coordinates basically, the x value stays constant for all the points that are on that line, right? So the x values stay constant for all the x values that are on this line, right? Meaning that our R value is equal to -1. So all that we need to calculate is our Y value. And then what do we see? We see that our point R is on our line SK. So this point R is on our line SK. So what we can do is use that equation that we got for our line SK, simply substitute this x value into that equation, and we can get the y value of R. And once we've calculated or got the y coordinates of R, then we simply use our distance formula to calculate the length of WR. I hope that makes sense. Okay, so let's do that. Let's get the y coordinates of our R. Okay, so we know that the equation of SK is this equation here. You remember, guys? I said it's this equation here, right? Which is y is equal to -2x over 5 minus 12. Alright, so we know that the equation of our line SK is equal to y is equal to -2 over 5x minus 12, right? And we know the x coordinates of our R, which is -4. So what we're going to do is we're going to substitute this -4 into this equation to get our y value. Alright, so let's do that. So y is equal to -2 over 5. We're going to substitute this -4 minus 12. Okay, just punch that into your calculator. So -2 over 5 multiplied by -4 is +8 over 5 minus 12, right? And therefore your final answer is -52 over 5. Okay, and then in decimal form, that is -10.4. All right, so we found our R coordinate, the coordinates of R, which is equal to -4 and -10.4. Right? Okay, so we found the coordinates of our R. Okay, so the coordinates of R is -4 and -10.4, and we already have the coordinates of W, so we just use the distance formula to get the length of our line, WR. So our W is equal to -4 and 4, and we know that our R is equal to -4 and -10.4, right? So using the distance formula, we know that WR is equal to x2 minus x1 all squared plus y2 minus y1 all squared, which is equal to, okay, like I always mention, I always label my points so that I do not get confused. So this is my 1 and this is my 2, right? So where my x2 is going to be your -4 minus your x1, which is -4 all squared, plus your y2 is -10.4 minus your y1, which is 4 all squared. So -4 minus minus, so that's going to be a +4. So it's just going to be 0 squared plus -10.4 minus 4. It's going to be minus. So it's -10.4 minus 4 is minus 14.4. Okay, so it's minus 14.4 all squared, all under the square root sign. And that is going to be equal to 4 units. Okay, so our WR is equal to 14.4 units. Okay, guys, So the next question is, now we need to calculate the size of our angle theta, right? So this is the angle theta that we need to calculate. But before we can even calculate that angle, right? This question is basically telling us that we need to basically calculate the angle that your line SK makes with your x-axis, alright? So we need to calculate the angle that the line SK or the line NK makes with our x-axis, right? So how can we get that angle? So this is a light bulb moment. In this case, you need to remember that this is basically testing what you know about an inclination of a line, right? And what do you know about an inclination of a line? When you're working with an inclination of a line, we know that the gradient of this line is going to be equal to our tan of that angle there, all right? So we have to calculate this angle here, but before we can calculate that angle, we need to get the angle that your line SK makes with our x-axis, right? And what do we know about our inclination of a line? Inclination of a line is equal to the gradient of that line that makes. I'm gonna write that down.
The gradient of line SK is equal to the tan of our alpha, and we got the gradient of our SK to be equal to negative 2/5, and that is equal to our tan of alpha, right? We're just going to punch that into our calculator, right? Press your shift 10 alpha, and we get our angle alpha to be equal to 21.80 degrees. Okay.
So we can conclude that our angle alpha is equal to 21.80 degrees. Okay. Let's just leave out the negative for now, right? So we found that our alpha is equal to 21.80 degrees, okay? And then obviously we can calculate our angle beta, right? By doing angles in angles in a straight line equal to 180, right? So we can basically calculate our angle beta by obviously doing 180 minus 21.80. So you can just say 180 degrees minus 21.80, and that is going to give you 158.20 point 2 degrees. So we already know what our angle beta is there, right? So we know that is 158.2 degrees, and we know that our angle alpha is 21.80 degrees, and that is because we obviously got our angle beta, because we know that angles that are in a straight line, right, are equal to 180 degrees. So now how are we actually going to calculate this angle theta here that we are actually supposed to look for? Okay, so what we're going to do is, now we need to basically try and solve or find the angles that are inside our triangle SNM, right? So we need to basically get the angles that are in this triangle, okay? And once we get these opposite angles, so the angle N and the angle, if we get the angle N and we get the angle M, then we know that an exterior angle, right, is equal to the sum of the opposite interior angles. Okay, so I'm just going to erase this and I'm going to explain this to you guys again. Okay, so we've already found our angle beta, right? We've already found this angle here, and we've already found the angle there, right? Okay, we found that our angle beta is equal to 158.2. Okay, and we found that our angle alpha is equal to 21.80 degrees. So now we still need to calculate our angle theta. So what do we notice about our angle theta? Okay, so I'm basically going to highlight this triangle. Okay. Our angle theta is an exterior angle for our triangle SN and M. Okay, so if we can get the opposite interior angles, then we will be able to get the exterior angle. Because what do we know about an exterior angle? An exterior angle is equal to the sum of your opposite interior angle. What are our opposite interior angles? Opposite interior angles is the angle N and the angle M. So if we can get those two angles, then we can get our angle theta. So now the question is, how do we get these two angles? Okay, so we already know that our angle alpha is equal to 21. We know that our angle alpha is equal to 21.80 degrees. And then what do we notice about our angle N? Angle N and angle alpha are vertically opposite angles, right? So our angle N is going to be equal to 21.80 degrees. Okay? So now what's left for us to do is calculate the angle M. Okay, so we need to calculate this angle M there. And how can we calculate the angle M? How can we calculate that angle? What do we see? Okay, so I'm going to highlight this line here. Okay, so angle M is on our line ST. Okay, and then what do we know about an inclination of a line? Okay, if you have a line, an angle that is created by a line and the x-axis is basically that inclination angle. And we know that that angle, or the gradient of that line, is going to be equal to tan of that angle that you are looking for. Okay, so we're looking for this angle there. Okay, we're looking for angle M. And to get angle M, we know that we can basically take the gradient of our ST. Okay, and this was given to us. Our gradient of ST is given as a half. Okay, so the gradient of ST is given as a half. So we know that when we're working with an inclination of line, we use the rule M on ST is equal to tan of, I'll call this lambda, okay, of lambda. Okay, and then we know that ST, the gradient of ST is equal to a half. Okay, I said it's equal to a half. So we're going to substitute that into our equation, and that is equal to tan of our lambda. Okay, so basically now we just need to calculate our lambda, okay? So it's going to be shift tan of that 1 over 2, and that's going to give you 26.57 degrees. It's actually 26.565, but then you're going to round it off to two decimal places, and it's going to give you 26.57. So we already now know that angle there that is created by our line ST and our x-axis, right? So that line, the angle lambda there is equal to 26.57. And what do you see about our angle lambda and about our M there that we're trying to calculate, or the angle M that we're trying to calculate in the triangle SNM, is that they are vertically opposite, right? So our M is going to be, okay, so our M is going to be 26.57, okay? And then from here, it really becomes simple, because like I had mentioned, is that if we can find your opposite interior angles, right, which is your N and your M in your triangle SNM, okay, then you'll be able to calculate the angle theta, right? And we know that the angle theta is equal to the sum, your exterior angle is equal to the sum of your opposite interior angle, right? So we can therefore conclude that, okay, therefore we can conclude that theta is equal to 21.80 degrees plus 26.57 degrees, and that is going to give you 48 point. So let's just quickly check that. 21.80 plus 26.57. Okay, 48.37 degrees. Okay, So that is our angle theta there, 48.57 degrees. And then the reason here, exterior angle is equal to exterior angle. And the reason is it's an exterior angle in a triangle, right? So that is the reason that you are going to get. Okay, so just a quick recap of question 3.5 because it's very important. Okay, the first thing is we needed to calculate the size of our theta. All right, so we need to calculate the theta. Okay, so what we already see is that we already have the line NR or the line NK or the line SK is making an angle with the x-axis, right? So we're going to start off by calculating that angle that is created by our line SK and our x-axis, right? And we know what the rules that we know in terms of an inclination of a line, okay, is that that angle can basically be calculated by you taking the gradient of the line, right? Your line, the gradient of the line SK, and making that equal to your tan of the angle that you're looking for, right? So our SK, we said that the gradient was -2/5, and we said that that is equal to tan of, we call that angle alpha. We call this angle alpha. Right? From there, we found that our angle alpha is equal to 21.80. Fine, right? Then now we also had to calculate our angle beta, right? And then what do we know about these two angles? We can see that they are actually angles that are in a straight line. And we know that angles that are in a straight line add up to 180. So we simply took the 180 and we minused it with your 21.80 to get our angle beta, right? So we found that our angle beta was equal to 158.20. That's absolutely fine. Then from there, we basically now needed to figure out how we're going to calculate our angle theta. So now we think, how can we get this angle, right? So we see that this angle is actually an angle that is outside our triangle SNM, right? So that means that we need to get the angle N that is inside our triangle SNM, and we also need to get our angle M that is inside our triangle SNM, right? And then we found that, this is simple. Our angle N is basically a vertically opposite angle to our angle alpha, meaning that our angle N is equal to 21.80, right? And then we also see that, okay, our angle M is an angle that is vertically opposite to the angle, we call this angle lambda there. So we created an angle lambda, right? But we don't have our angle lambda. So how do we calculate our angle lambda, right? Lambda, potato, potato. Okay, so we basically now are like, okay, we also know the rule of an inclination of a line. If you have a line and that line makes an angle with the x-axis, then we can calculate that angle there by using the rule that the gradient is equal to the tan of what that angle that you're looking for. So that's what we did here. And we found that the gradient of our line ST was equal to a half, and then we said that it's equal to tan of our lambda. Okay? And then we found that after doing our calculations on our calculator, our angle lambda was equal to 26.57. Right? After getting that 26.57, we saw that, oh yeah, they're actually vertically opposite. So we just quickly substitute that 26.5 into the M value in our triangle is in M. And then from there, it becomes so simple because we can see that our angle theta is equal to the sum of our interior opposite angle. And that is just the rule that you need to know in Euclidean geometry. Okay, we know that angles in a triangle equal to 180. We know that angles in a straight line equal to 180. We know that an exterior angle is equal to an opposite interior angle. So those are all properties of a triangle that you should know, right? Okay, I'm going to actually make a video where I go through the properties of triangles for you guys to make life easier. Okay, so that's it. And then from there, we found that our angle theta is equal to 21.80 plus 26.57 degrees, and we found that our theta is equal to 48.37 degrees. And the reason that you give here is that exterior angles in a triangle. It's an exterior angle in a triangle. You know that an exterior angle in a triangle is equal to your opposite interior angle. Whoa! Okay, I actually love this question. I love this question so much. It requires you guys to think. It requires you guys to know your work. It's testing whether you guys have studied. It tests whether you guys understand your concepts. That's why I can't stress this enough. Make sure that you have gone through the summary tutorial that I've created for you guys. It's going to help you so much. Alright guys, and the final question. Let L be a point in the third quadrant such that SWRL in that order forms a parallelogram. Calculate the area of SWR and L. Okay, so let's just see what this question is actually telling us. Okay, so we basically have SW, so this is my S, that is my W. Okay, and from W you go to R. You go to R. And from R, you go to a point L that is in our third quadrant. So you're going to have a point L somewhere there. Okay. And that point L obviously will connect with our point S. And we need to calculate the area of the parallelogram, which is SW, R, and L. Okay. So in this question, they are testing to see if you know the properties of a parallelogram. They're testing to see whether you know all the properties of a parallelogram that will help you to calculate the area of the parallelogram SW and L. So now, what do we know about the properties of a parallelogram? We know that the opposite sides are parallel. We know that the opposite sides are congruent as well as the opposite angles. We know that the consecutive angles are supplementary. And we know that the diagonals bisect each other at 90 degrees. Okay, so I'm also going to just fill out that information there that we've got your diagonal. So the first diagonal is S and R, and the other diagonal is your L and your W. I actually forgot to put our point L there. So that is our L. Okay, and we know that the diagonals bisect each other at 90 degrees, right? So there, that is basically 90 degrees. Okay, and then we basically need to calculate the area of SWRL. Okay, guys, I'm sure you can see that it's going to be pointless, right, to calculate the area. Okay, so we basically have to calculate the area of SWR. So looking at the properties that we know of a parallelogram, right, if we calculate the area of triangle SWR, then we can just simply multiply that value that we would have obtained for that area by 2, because we know that opposite sides are congruent. Okay, so if now this side and that side are congruent, that side and that side are congruent, so if we calculate the area of just the top triangle, then we can just simply take that area and multiply by 2, and that will give us the area of the bottom triangle. Right, so that's what we need to do. Okay, so now let's try and calculate the area of the triangle. What do we know about calculating areas of a triangle? So basically what we need to do is we need to calculate the area of triangle SWR. We need to calculate the area of triangle SWR, and then from there we can just simply multiply that area by 2, and then we will have the area of the parallelogram, right? So how can we calculate the area of triangle SWR? The formula for an area of a triangle is given by, so we need to calculate the area of triangle SW and R, okay? And then we know that the formula of the area of a triangle is given by your half base multiplied by your perpendicular height, okay? So at this point, we just need to determine which one is going to be our base and then which one is going to be our perpendicular height, alright? So let's look at our diagram, okay? So then I'll say that my base is going to be, so this one is going to be my base, your SR is going to be my base, okay? And my perpendicular height is going to be OW. Okay, so I'll call this point O there. Okay, so now we already know what we need to calculate, or what we need to basically calculate the area of our triangle, right? We basically need our perpendicular height, so the length of SW. We need to get the length of SW because that's going to be our base, and we also need to get the length of our OW because that's going to be our perpendicular height. Once we have that, then we will be able to calculate the area of this triangle, right? But then how do we get to that? How do we get our SR and our OW? Okay, so the first thing we need to do is we need to obviously calculate the length of our line SR using the distance formula, all right? So what's the distance formula say? Okay, so I'm just gonna write down what we are working towards. Okay, so this is what we are working towards. We are trying to get our half and then our base. We said it's going to be your SR multiplied by your perpendicular height, which is going to be our OW. So those are the values that we are trying to get. Okay, guys. But before that, we need to calculate our SR. Okay, so how do we get our SR? We can get SR by using our distance formula. And we know the equation for a distance formula is x2 minus x1 all squared plus y2 minus y1 all squared. Remember, I always say that I love labeling my points. So if my S is my 1 and my R is my 2, then we're going to simply substitute those values there, right? Do you guys still remember what the coordinates of our S was? Our coordinates for our S, we already got them to be equal to negative 20 and negative 4. And we found that the coordinates for our R is equal to negative 4 and negative 10.4. Okay, you guys still remember? Okay, so we found the coordinates for S, we find the coordinates for R, then we can simply use our distance formula, substituting these coordinates to get our length of SR. So let us do that. Okay, so my S, I'm just going to put this there so that you can see, is negative 20 and negative 4. And my R is equal to negative 4 and negative 10.4. And then I said that my point S is the first point. Okay, and then I said that this is my first point and that is my second point. We are simply going to substitute this into our equation, guys. This is really easy because we've been doing this a lot now. Okay, so it's going to be x2, which is minus 4 minus 20, which is going to be plus 20. Minus and minus is your positive, right? So it's all squared, plus y2, which is the negative 10, negative 10.4, right? Minus, right? Minus, so it's going to be positive. Guys, let's simply punch this into our calculator and we get our SR to be equal to 16 square root 29 over 5. And then that is 17.23. Okay, so we're going to head on to our diagram and just fill in what we got for our SR. And we said that our SR is equal to 17.23. Okay, so your SR is equal to 17. So we've got that, but we need our perpendicular height, guys. So how can we get our perpendicular height? Because that's what we still need to get, right? So you can either use, obviously, the value that we got, or calculate your SW, the length of your SW, and you can use then you can simply use your trig identities to help you calculate your OW. Alright, so we're going to start off by just getting your SW, guys. Same thing here, we are just going to use a distance formula. We already know what our coordinates for our S is. We already know what our coordinates for W is. We simply use the distance formula to get your length of SW, and then we're going to use our trig ratios to get what the length of our OW is going to be, and then from there we can calculate the area of our triangle. Okay, so let's just do that, guys. Let's get the length of SW. Alright guys, so I basically paused the video to calculate the length of SW, and I've got that my SW is equal to 17.89 units, alright? And I also just to okay, so our SW is equal to 17.89 units and our SR is equal to 17.23 units. Alright, so I'm just going to fill that into our diagram so that you guys see what is going on here. Alright, so like I said, we said that our SW is equal to our 17 point. So the SW is equal to 17.89 units. Right, so we've got now our length of our SW and we've got our length of our SR. So we can get to the length of our OW using trig ratios, right? We've got this angle here, guys. Do you still remember what it is? It is equal to 48.37. So we got that angle. So basically what we can do is we're looking for our opposite side, right? Which is our OW. We're looking for OW. So we can just simply use our trig ratios to get our OW. Let's do that and see where we get. Okay, so we can basically say that, I'm just going to write it here at the side. We know that sine, okay, cosine of theta, we know that, okay, let me actually just remind you guys of our trig ratios, which say that we know that it's, we use the whole SOHCAHTOA, right? So we know that sine of theta is equal to opposite over your hypotenuse, right? Okay, and then our opposite side, okay, so I'm just going to put that down here. So we know that sine of theta is equal to your opposite over your hypotenuse. We know that our theta is equal to 48.37. So we're just going to fill that in. So it's going to be sine of 48.37. So we know that sine of theta is equal to opposite over your hypotenuse. We know that theta is equal to 48.37. So we're just going to fill that in, okay? So it's going to be sine of 48.37, okay? So what is our opposite side? Our opposite side is our OW. So that's the OW, and that's what we are looking for. Okay, so I'm just going to put it as OW all over what is my hypotenuse, and my hypotenuse is my SW. Why is this my hypotenuse? Because this is the side that is opposite the right angle, right? So that is the SW. Okay, so we're just going to fill in those values again. So it's going to be sine of 48.37, which is equal to OW all over. We found that our SW was equal to 17.89 units. Okay, so we're going to put that in. So it's 17.89 units. Okay, so you're going to basically multiply that 17.89 by your sine of 48.37, and that will help us get our OW. Quickly put that into your calculator and you'll see that your OW is equal to 13.37, okay, units. Okay, so we've basically calculated our perpendicular height. Okay, so we found our OW to be equal to 13.37, and we also found that our SR is equal to 17.23 units. Okay, so we found that to be 17.23 units. Okay, so basically now we are going to be working with the formula. So it's going to be half our SR, which is equal to 17.23 multiplied by the perpendicular height, which we found to be our OW, and we found that our OW is equal to 13.37. Okay, you put that into your calculator, you found that you get 115.18. Okay, and guys, this is basically the area of triangle SWR. So we basically, okay, this is unit squared, okay? This is the area of our triangle SRW, okay? So we've calculated the area of triangle SRW, right? So basically, and we found that the area for triangle SRW is equal to 15.18 units squared, right? And then to get area there, what do? We just take that area that we obtained and you simply multiply by 2. Okay, so we can get the area of, therefore, the area of your parallelogram, which is S, the area of SW RL is equal to 2 times 115.8. 115.18, that is equal to, so we found that the area of the parallelogram SWRL is equal to 230.37 units squared. So that is it for today's tutorial, guys. You answered all the questions that were required to answer, and I hope the approach that I used in answering these questions helped you better understand all the important concepts that you guys should know and understand when it comes to analytical geometry. Alright, if you enjoyed the video tutorials, please make sure that you are subscribed to the channel. I will be uploading question 4 of this paper in the next tutorial. So please do make sure that you are subscribed to the channel. And question 4 covers circles in analytical geometry, right? So I'm going to be showing you guys just easy, simple, straightforward ways that you guys should approach this question. So make sure that you are subscribed. Make sure that you hit the notification bell so that you get notified when I upload the next video. Happy studying, guys, and I'll see you guys on my next tutorial. Goodbye.